Hello. Question 15. It says, consider the equation 4x squared plus kx plus 1 equals 0. For what values of k does the equation have two equal roots? We know that that's going to be a bounce or a repeated root. And it just touches the graph. Or it just touches the x-axis one time. That means that our discriminant is going to be equal to 0. So let's calculate the discriminant of this quadratic. A is 4, b is k, c is 1. B squared minus 4ac is equal to 0 since this discriminant only has one root. And since this quadratic only has one root, and we have k squared minus 4 times 1 equals 0. K squared minus 16 equals 0. K equals plus or minus 4. Next, let f be the function f of theta such that 2 cosine 2 theta, oh, I see a double angle, I'm going to mark that, plus 4 cosine theta plus 3 between negative 360 and positive 360. Oh, they're just telling us about it. Okay, show that this function may be written as f of theta equals 4 cosine squared theta plus 4 cosine theta plus 1. So this double angle cosine somehow turned into a 4 cosine squared. So that's the double angle formula that I am going to use. I'm going to take the 2 and I am going to turn the cosine 2 theta into 2 cosine squared theta minus 1. And that came right off my formula booklet. Or hopefully for you, it just came right out of your head because it's much faster to remember them. Then now I'm going to distribute. I get 4 cosine squared theta minus 2 plus 4 cosine theta plus 3. I'm just trying to match the structure to the thing listed right up here. And I have 4 cosine squared theta plus 4 cosine theta plus 1 equals this piece right up here. Okay. Now it says consider the equation f of theta equals 0. So that means this is f of theta, and I'm going to be setting it equal to 0. So that means I would have 4 cosine squared theta plus 4 cosine theta plus 1 equals 0. That's what I'm doing right now. And I'm going to find the distinct values of cosine theta that satisfy this equation. This is a very sneaky way of telling me that I'm trying to find the zeros of this guy. And I'm going to be on an interval from this to this. This is a calculator question. I have the urge to solve this by hand, but I'm going to resist that urge for time's sake. I'm going to use my calculator instead. So I have 4 times. Remember, when you're typing in cosine squared, you're going to have to do it in parentheses. Get out of there. Okay, this thing is making me mad. Okay, there we go. Plus 4 cosine of x plus 3 plus 1, sorry. Is that right? Yeah, looks good. Okay, so then now I can't see my graph, and that's because I am not in well, I'm in degrees, but I'm not in the correct window. So sometimes if you hit zoom trig, it'll adjust it for you. Ooh, it did. Fantastic. That's a good time saver. Okay, so how many times does this graph cross the x-axis from negative 360 to 360? 1, 2, 3, 4. So there are 4 solutions. So you would say 4 distinct values. And you can just include a little sketch of the graph if you want to be your... What happens to this thing in between here? How high does it go up? Oh, that's way too high. So it looks like kind of like a weird little 2 W's or something. Okay, so we'll do that. And then that's enough math to show that you know what you're doing. So that's your 4 solutions, okay? And then what else? Let's see. Find all values of theta which satisfy this equation. Okay, so now we actually have to find what those solutions are. Okay, so let's find them on the graph. All right, so negative 240 degrees. Negative 120 degrees. And I'll put these on the picture so that way, like, whoever is grading your paper knows exactly where you got them from. Okay, then it says, given that f of theta equals c, so that's going to look like a y equals c, so that's going to be some horizontal line, right? We got to figure out what that equals. So that way, is satisfied by, so kind of crosses only 3 values of theta. Find the value of, I guess C didn't print, find the value of C. Okay, so we are trying to find the equation of the horizontal line that only hits the graph of f of theta 3 times. So it looks like right up top here at like this piece, and this piece, that's going to be 3 solutions right there. Boom, boom, boom. So how do I find the equation of that y value? I'm going to analyze the graph and make sure all 3 maxes are happening at the same spot. So that max is happening at 9, and then I need a little bit more space over here to see what happens at the turning point, kind of. Just to make sure. I just want to make sure that all the maxes are even, right? Because what if like one of them was taller than the other? Okay, so far that one's 9 too. Okay. And then this one is also 9. Okay, also, so there is a horizontal line, y equals 9, that will cross this graph only 3 times. Okay, so we're going to write c equals 9. And we're just going to draw a little sketch to kind of model that. Okay, so I have my graph that looks like this, right? And then I want to show that when it passes through this point here, it only hits 3 times. Okay.